Hello and welcome to the Fill in the Blank Programmer. This is the channel where we talk about all manner of things related to programming. In this episode, I want to talk about pointers. What the heck is a pointer? And I think I can do a pretty good job of illustrating exactly what a pointer is. Now, as always, check out the video description for important news about upcoming things and such. So I just have a value here. It has the value 42, and then I have a pointer. Now I am in C++, but what exactly is a pointer and what is a value and what does it mean? And I think we'll be able to come up with a reasonable explanation here. So I'm going to go ahead and I'm going to print out a few things. Okay, so we have this value 42, that is value, and then we have this thing called p. And p currently has the value OX7FFFCC541C0C. And what in the world does that mean? Now, it would have been much simpler if I could have demoed this on, say, a 16-bit platform or even an 8-bit platform. We're on a 64-bit platform right now, so we're gonna have to, well, we're just gonna have to roll with it. So that is the value of p. We still don't really know quite what that means, but this is something that has a value. So I'm going to go ahead and print out a couple more things. Okay, so we have two things to discuss. We've got the fact that we have a value and we have a pointer to that value. And then we also have the thing that the pointer points to, and we have the address of both of these things. Okay, so now we're going to see, unfortunately, these things move around in memory, probably. But we can see the value is 42, that's what we expect. Now this ampersand here in C and C++ says, give me the address of this thing. It's saying, give me a pointer to this thing. So if I print out P, which is a pointer to value, and the address of value, then I expect the same thing to be printed. And in fact, they are. And then if I say print out the address of P, I see something slightly different printed. Some value slightly lower in the stack. So what we're getting here is we have in memory on the computer right now a bunch of different addresses that are in use. So your memory is going to start at something like this. And you've got lots and lots of addresses until we get down to where the stack is currently being stored. And it's clearly something around this location. But we can see that it's constantly changing. So let's go ahead and do a copy and paste of these values. Okay, so we're looking at something kind of like this. These are the address ranges that were printed out to us by our runtime here. And this is the start of memory, and towards the end of memory somewhere we have the stack. And we have two values on the stack. We have value, and we have this pointer p. Okay, so let's go ahead and try to decipher what this actually means. This is telling me that my value 42 is stored at this memory location, CB4. So we're going to start down here. Now, the Intel processors use something called Little Endian, and that's, to be clear, Endian. That means that the values are stored with the least significant bytes first. So what we would see here is that we expect that we actually have the value 42. That's in decimal. The value 42 stored at this location. Now this is a 32-bit signed integer. So that's just the first 8 bits, 16 bits, 24 bits, and then 32 bits. We can reason that these memory addresses store these values. It's 42 followed by 3 zeros. And so that is what this pointer is. The pointer value p that points here says that it is actually pointing, all it is an integer that's stored in another memory location. So we know that the pointer itself starts here. And again, we know the least significant is first, and we know the thing that it is pointing to is this. So it ends up something like this. And these are hexadecimal values. So those are the 6 bytes of the address, and then we know that the most significant bytes are themselves the value 0. So what is a pointer? It's just a memory location that stores another memory location. That's all it is. It's a value interpreted in a particular way. If we were just scrolling through memory, if you will, in this program, and started dumping out the bytes, would we get to here and say, well, obviously someone has the value 42 stored? Well, maybe we could see that and we could reason about it. And maybe we could see this and say, that kind of smells like a stack pointer. I don't know. Maybe, perhaps, this is what people who reverse binaries do and that kind of thing. Although we can see an interesting artifact of padding and such here, because we can see that this thing, the pointer, is aligned for 8 bytes, and then we skip 4 bytes, and then we come and have the 4 bytes that represent our 32-bit integer. And if we really wanted to, now we would absolutely be invoking undefined behavior, but we can probably actually write a little program that does this output for us, and we can maybe kind of see this ourselves. So let's go ahead and try to dump the memory that is right here. We're going to start at the bottom item because we know that's going to be the highest memory address. Well, let's see what we can do. I'm not going to pretend like any of this is a good idea, but I think it does let us peek behind the curtain like we wanted to. So we can see that we have the value 42 and it exists at this memory location. 32 F0 9654. 32 F0 9654. In fact, there is the value 42 and it's 3 0 bytes following it, exactly like I said would happen over here. Okay. And then our pointer, P, resides at this address starting at 48. And at 48, we see the actual location of our integer here. That's 54, 96, F0, 32, FF, 7F, and then 0, 0. So what is a pointer? It's a value that represents a memory location. We can interpret these bytes in any number of ways. As you can see, I have both the hex and the decimal representations of these numbers being printed out here. And I just by looking at this simple code, interpreted differently. Okay, I wanted to look at the decimal here because I know it's the value 42. I didn't want to look at the hex here. But here I wanted to look at the hex representation of the same bits. They're the same value, they're the same bits. It's just a different lens of looking at them through. So a pointer is a value that represents a memory location. And don't write code like this. But thanks for watching this episode of the Fill in the Blank Programmer. I hope you enjoyed this, and be sure to subscribe. I hope you learned something new.